In this lesson, we're going to look at how to find the volume and surface area of cylinders, and then we'll look at a problem of how to calculate that. But first, we're going to be looking at how do we get the formula for volume and surface area of cylinders. Well, a cylinder, of course, is like a can of pop or any type of can that has a circular base and goes upwards. It's a three-dimensional shape. And the main things we look at is it has a radius. The base has a radius because it's a circle, and the height is the distance between the two bases. Well, we're going to look at how do we find the volume of this? Well, thinking about any type of prism, we usually find, like a box, base, length times width times height. How we can also think of that is we find the area of the base and multiply it by the height. Well, we know the area of the base because it's a circle. A circle has an area of pi times r squared. Now volume is the area of the base times height, and if the area of the base is pi r squared, the volume is pi r squared times h, or pi times r squared times h. So that is the formula for volume. Now what takes a little more thought is what is the surface area of a cylinder. Now the surface area of a cylinder, we have the same idea, same shape. Surface area, remember, is all of the area on the outside of a three-dimensional shape. So part of that would be the top and the bottom. Well, that's easy. Again, that's a circle. The area of the base is pi r squared. And how many bases are there if it's a closed cylinder or can? There's two of them. So we would add 2b, which would be 2 pi r squared. That gets us the top. But what about the sides? How do we get the area of the side? Well, let's take a look at a toilet paper roll here, which is a cylinder where we don't have the top and bottom. What we can think about is we want to know what's the area of all the sides of this. So what we can do is actually take this and cut it open and think about what shape is it if we cut it open. Well, if we look, it becomes a rectangle. Now we know the area of a rectangle is the base times the height. But what is this base? We already know the height is just the height of our cylinder. But think about the base is the distance around the circle. If we're talking about a circle, the distance around a circle is circumference. That's 2 times pi times r. So that means the area of this is 2 pi r times h. So from that we get the area of the side is 2 pi r h. And there's only one side, so surface area is 2 bases plus the side, so 2 pi r squared plus 2 pi r h. This right here is the surface area formula. So we're going to look at how to use that and the volume formula, pi r squared h, to get the volume and surface area of a can. Let's take a look at this problem here, which says a soda company is producing a new can size. It's a cylindrical can with a radius, so let's write down our major ideas here, a radius of 6 centimeters and a height, h, of 9 centimeters. The company wants to know how much soda the can will hold and how much material is needed to create the can. So remember, volume is space inside, so how much soda the can will hold, that's volume. And how much material needed to create the outside of the can, that would be surface area. So if we go back, our formula for volume is pi r squared h. So we can plug all this in. Pi times 6 squared times 9. 6 squared is 36 times 9. We can use a calculator for that. 36 times 9 is 324. So what we get is pi times 324, and we can use a calculator again for that. And we get is 1017, let's say 0.9. 1017.9. And our units are centimeters because it's volume, it's centimeters cubed. That's our volume. Surface area, we had quite a mouthful here. 2 pi r squared plus 2 pi rh. So we're going to put all of that in. 2 times pi times r squared, so 6 squared, plus 2 times pi times 6 times height, 9. So all of this together, 6 squared is 36, and 2 times 36, we get 72 pi, plus 6 times 9 is 54, times 2 is 108, we get 108 pi, and we can do this on our calculator too. 72 pi plus 108 pi equals, we get 565.5. 565.5. Now surface area, we're talking about a three-dimensional shape, but we're talking about the flat area. That means we're talking about units squared. So surface area is centimeters squared. So we get that the material used would be 565 square centimeters, or 565.5 square centimeters, and the amount of soda it could hold is 1017.9 cubic centimeters of soda. So the two formulas you want to remember for this are the volume, pi r squared h, and our surface area of a cylinder, 2 pi r squared plus 2 pi rh. And remember, you can derive that by taking any cylinder and think about the areas of the bases, and how if it unfolds, it's just the circumference of the base times the height. So now you can go on to the practice assignment, and then once you finish that, move on to the assessment.